Okay, so that's our definition. We count all the possible outcomes, we count favorable outcomes, and we divide those two numbers. I guess it's clear that number of favorable outcomes can never be more than the total number of outcomes. So if there are only two outcomes, two possible outcomes, you can't have three favorable outcomes because there is only two and you can't have more than two, and so on. And consequently, your probability will never be more than 1. So it will always be between 0 and 1, or between 0 and 100% if you talk in percentages. And also, if you take, so let's look here, for example, we have two outcomes for a coin. Each of them has a probability of 1/2 or 50%. And if you add up all the probabilities, 50% plus 50%, you get 100%, or you get 1. The same for a gaming die, 1/6 for 3, 1/6 for 1, 1/6, 1/6, and so on. And again, if you add them all up, you will get 1, because 6 times 1/6 is 1. And that's the case for any conceivable situation. So if you calculate the probabilities for all possible outcomes of an event and you add them all up, you will have 1. If you get less than 1, then most probably you have lost 1 or 2 or more of the outcomes. You did not count all the outcomes. If you get more than 1, then you definitely have an error in your calculations somewhere. So that's a quick way of checking whether you are doing everything right or not. Excuse me. Okay, so what else? The probability of an event is not a very, well, how do you put it? It's not always a fundamental thing. So looking at this, for example, it might seem as the probability of an outcome of a coin toss is something that's inherent to the coin. It's like some kind of a physical property of a coin or something like that, or a physical property of a die, like its mass or its size and so on. But it's not true. Probability depends not only on the event itself, but also on our knowledge about the event. So again, if you've read the transcript, there are two questions which look very similar. So first of them is, let me read it out loud. So you are rolling 2 dice. What is the probability of the product of the rolled numbers being 8 and their sum being 6? So you roll 2 dice, you got the numbers, and you multiply the numbers, you get 8. If you add the numbers, you get 6. What is the probability of that thing happening? So here I have two tables, one for the sum of 2 dice rolls. Yeah, so if both of them are rolled 1, you get 2 in their sum, because 1 plus 1 is 2. You get 3 for 2 and 1, you get 3 for 1 and 2, and so on. And we can see that there are let me colorize those outcomes, right? So it will be easier to see them. Oh, sorry. So here are 5 cases where you get 6 as the sum of dice roll. Yep, in all other cases, you have either more than 6 or less than 6. And in this table, we have the products of two dice. So multiplication of two dice. And there are only, oh, let me use a different color. Maybe, I don't know. I'll let it be blue. So we have two cases where the product is 8. We have 5 cases where the sum is 6. We want both of them to happen at the same time, and I see that this cell in here does have both the sum of 6 and the product of 8, right? It's when one dice is 2 and another dice is 4. Let me change the color for that cell, and I will use green. And here's the another one. So again, I'll mark it green. So in these two cases, you have the sum of your dice being 6 and the product of your dice being 8. So that's exactly those cases which are favorable for question 1 in the transcript. So that's page 2 of the transcript if you want to look it up. So we have 36 different possible outcomes, and only 2 of them has both the sum of 6 and the product of 8. And well, how do I put it? Well, I will write it down this way. So probability of, let's mark one dice roll by X and another dice roll by Y. So probability of X plus Y being 6 and X times Y being 8 is 2 over 36, right? Or 1 over 18, because we have 36 in total, 36 different outcomes, and 2 of them have both the sum 6 and the product 8. And then there is another question. So you are rolling 2 dice again. What is the probability of the product of the rolled numbers being 8 given that their sum is 6? So it looks like it's just the same question, right? It looks very similar, but in fact there's a difference. There's an important difference. So let me bring it on screen just so that you can see the, okay, I'll make it this way. I'll share the whole desktop. So look here. Here the questions I'm talking about. So let's analyze that. The first one tells us we know nothing about the dice. We know that there are 2 dice rolled, and we want to know what's the probability of this and this happening at the same time. So we know nothing about the roll again. And that means, so if we know nothing, there might be 36 different possibilities, like we see here in the table. And we know that 5 of them are favorable for this one, and 2 of those 5 are favorable also for this one. So we calculate our probability and we get 2 over 36, as we have already seen. And in the second one, pay attention to the wording, given that their sum is 6. So we already know that the sum of the dice rolls is 6. So we can be sure that dice are in one of these 5. So again, let me outline that. In one of these 5 what do we call it? Configurations, combinations. So let's go back to our Excel. It's here. Oh, I need to stop annotation first, right? Yeah. I'll clear all the drawings. Okay, so we are back. So we can be sure, yeah, it's for one. And for the second one, let me put it here. X times Y equals 8, given that X plus Y equals 6. Oh, yes? Any questions, Sardar?
I have a question. Why would you have like that kind of 36 probabilities?
Well, look, how many ways are there? So let me put it into words. How many different combinations of two dice are there? So each die has 6 faces. Let's call it maybe a red die and oh, sorry. Sorry. So a red die maybe and a blue die. Well, just to discern them, it does not mean that dice have to be colorized. It's just so we can separate them now. So you can have a red die being 1 and the blue die being 1. Yep, that's one combination. Let me put it here, 1, 1. Or you can you can have red die being 1 and blue die 2, or 1 and 3, or 1 and 4, and so on and so forth until you get up to 1 and 6, and then you can have red die being 2 and blue die being 1, and then 2, 2, and so on, and all the way up to 6, 6. And if you count all that possible combinations, in fact they are here, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on, you will get 36 different combinations. So that means that when you are rolling 2 dice, you will have 36 possible outcomes. So all the possible outcomes and their number is 36. And that's if you know nothing about the dice in our first case. But in second case, we know that the dice have come up in such a way that their sum is 6. So we know that those dice are in one of these 5 combinations. So let me put them here. So it's either 1 and 5, or 2 and 4, or both of them are 3, or 4 and 2, or 5 and 1. Yep, so the only possible ways we can get 6 is these 5. So here we know that the dice are in one of these 5 configurations. So there are only 5 possible outcomes in total. And we know that 2 out of those 5, namely 2, 4, and, oh, just a moment. So 2, 4, and 4, 2. So in these 2 cases, we will have their product be 8. So out of these 5,
Teacher, I wanted to say,
yep.
I want to say that 2 of our students cannot join the lesson. Could you open for them as well?
So, oh, I see now. I see now. Okay, I'm admitting. Yeah, that's okay now. Okay, so we have 5 possible outcomes in second case. and 2 of them is the ones that give us 8 in product. So probability in this case will be 2 over 5, which is about 40%, I guess, which is much more than this one, 1 over 18. And that looks strange. We have almost the same events essentially, and the only difference is that here we know nothing and we want to know the probability for this and this, and here we know for sure that this is already realized. Oh, how come I did not merge the cells? Okay, so our
Also,
knowledge,
the quality of video is a bit low. That's not obvious. I mean,
well,
that's not true.
most probably that's because bad connection or something like that. So let
Mm-hmm.
me change the scale maybe. So what if I do it like this? Can you
Yeah,
see
it's
it now?
better. It's better.
Yeah.
Sure.
Anyway, in any case, I will upload the recording to to YouTube most probably a bit later. And I suppose anything that was unclear here in terms of video quality, I guess you can just watch the recording after and make it clear there. But anyway, if you can't see something or something is too small or the quality is too bad, feel free to ask me, so I will zoom in or make it more clear in some different way. Okay, so the only difference here between these two is our knowledge. And yep, more questions?
Nuruddin Malakhat is gonna join.
Sorry?
Once one of the students is gonna join, Malakhat Nuruddin.
Okay, but right now there's no one in the viewing room. Maybe she didn't connect yet.
Okay, now I'll. Okay.
Yeah, well, there's no notification for admission. Okay, so as soon as she connects, I will just admit her into the conference, and I guess it will be all right. Well, I guess somewhere here we should have, yeah, maybe if I turn this off, maybe now they won't need my approval for joining. Let's try. Okay. So our prior knowledge has decreased the number of possible outcomes. Yeah, we had 36 when we knew nothing, but then somebody told us that the sum is 6, and instead of 36 different outcomes, we now have only 5 different outcomes, because all the others do not give 6 in sum. Okay, that's about the definition. So let's pause for about, I guess, 3 or 4 minutes, and then we will move to the next part of the topic. Be right back. I won't stop the conference, so feel free to discuss anything you want.